Alright, so notebooks. And today we are talking about angle measure.
Angle measure?
That's what I said. Angle measure. So yesterday we did segment measure. And actually I'm going to go over a little bit more some of the segment measure stuff. So here are, now in your notes, you're going to want a section that is dedicated to theorems, postulates, and definitions, because you're going to need those readily available for when you do two-column proofs, and you're not going to want to be hunting through your textbook and your notes to find them. You're going to want them all organized in one spot. So the following two definitions that I give you, you're going to want in your notes, but you're also going to want in a separate section, perhaps at the end of your notes, where you have all of them. There are going to be an awful lot of them, so that's why I tell you that. So you're going to want to copy this in another spot as well.
What definitions are they called?
Postulates, theorems, definitions. So and I'll tell you when they should go there. So these two you want in your notes, but you also want in a separate section that you can reference really quick. So the first one is segment addition. I know we're talking about angle measure, but these are similar, so we can put this one here. Segment addition. This is very, very simple. And actually, the angle one is very similar. It basically says the sum of the parts equals the whole. So if I take segment here, AB, and add to it segment BC. So if I take AB and I add to it BC, I get segment AC. Yeah, I got a pile here. Thanks. Yep, no problem. Okay, so that's segment addition. And angle addition, very similar. In fact, it's the same. Sum of the parts equals the whole. So in the case of an angle, like maybe I have an angle like this, with another ray in the middle there. So I'll have angle A, P, B, and angle B, P, C. So hopefully you can see, just please look up so you can see what I'm doing here. If I take this piece and I add to it this piece, hopefully, common sense, you get the whole thing, right? Mm-hmm. So you're going to find that when you're doing proofs, that you're going to be proving something that is common sense. For the most part, you need to justify, and that's the point of this class for the most part at the beginning of the year, is just to get used to logically thinking through things and how things work. So written out, this would be angle APB plus angle BPC. Remember, we have the vertex always in the middle. It's going to equal the whole thing. Angle APC. Now, when you're doing a proof, on the left you would have your statement, and on the right you would have your reason. And for your reasons, these definitions would serve as reasons. You don't have to write sum of the parts equals the whole. You simply write segment addition, angle addition, and that's all you need to say. Now, if you forget those, you could write out this whole thing, and that would be fine. Okay, but I want to save you some time. All right, so today we're mostly going to be working on angle addition. We're adding the different parts of angles. We're also defining some angles. And let's go ahead and define some different angles. So we have acute angles, and hopefully you've already heard of those before. And these are angles whose measure is less than 90 degrees. That's an acute angle. So like this, that's acute. Yes?
Is this still part of those special notes that we need?
No. Okay. Just those definitions.
Mr. Kennedy, you're going to get really mad. Will you please go back?
Actually, yeah. This will be posted at 4. So if you miss something, you can always go back. All right, so acute angle. Then we have a right angle. This is a measure who's equal to 90 degrees. looks something like this. And we generally will mark with a little box there so that we know that that is a right angle.
What does that M stand for?
Measure. Thank you. That's how I'm using it. Yes, measure. Okay, then we have obtuse. The measure is greater than 90. So something like this. That's an obtuse angle, bigger than 90. And the last, and you should have done this like since, I want to say 6th grade. So these should be very familiar definitions for you. A straight angle has a measure equal to 180 degrees. And that actually gives us a flat line. Okay, and you'll want to recognize flat lines of having 180 degrees. Okay. I am going to do something dangerous and assume everyone in here can use a protractor to measure an angle. If you cannot, that is fine. See me before school. I'm here at 7:30. Say, Mr. Kane, teach me a protractor. Now I'll show you. You do need to be able to use one to measure. And I have hundreds of them. If you don't have one, don't buy one. It's okay. There's hundreds of them. I could just give them out. I could give you all one right now. But I will talk briefly about a protractor and how to read it, because sometimes we do get confused here. You don't have to draw this and just kind of like, here's a protractor. If you have the good one, the good kind, there should be like a crosshair in the middle with a little point. That's where the angle vertex goes. And then one of the rays, so I'll do a different color, one of the rays needs to point to, does anyone remember?
The
No.
right.
0 degrees.
No.
We are trying to get a measurement. You need one of the rays to point to 0 so that you're counting up. Okay? If you have the good one, on both sides, it will have both 0 and 180. You, of course, are going to do the reading of the numbers from the side that says 0, so that you're counting up. And then the other ray would be pointing to whatever the measure is. Use some common sense when you're measuring. If it's an obtuse angle, you expect an angle measure that's bigger than 90. So if you get an obtuse angle and it's not bigger than 90, then you are reading the wrong set of numbers on your protractor. And most of them do have 2 sets of numbers on them. That's why I say one of the rays must point to what number?
0.
0. And the other one will point to the degree measure, whatever it is. So make sure you use some common sense on that. All right, so what might we use this angle addition postulate for? Well, here we have a whole big angle, and we'll have a little piece in here. And we do use hash marks on angles, so if this is 20 degrees and this is 30 degrees in here, what might we say is the entire angle?
50.
50 degrees. Pretty simple, right? And then if I use a similar example, let's say this is 10 degrees in here, and let's say this is, I don't know,
30. Oh.
and let's say right here, this is 30, Daniel, just for you. What is x?
20.
20. Okay, does anyone not see why that's the case? Well, good. So either you're all afraid to tell me or you're smart. Okay, so I'll go with you're smart. All right, so let's get some algebra in here. Oh, come on, stop it. All right, so we have x plus 10, and let's say we have 2x, and let's say this whole thing is 60. What do you think we should do in order to find, now let's get some other things here, A, B, C. Let's say I want to find the measure of angle, see, M, measure of angle A, B, C. What should we do, Jacob?
Well, you need to set up the equation 2x plus x plus 10 equals 60.
Okay.
Combine the terms.
Subtract.
3x plus 10 equals 60. Subtract the 10. Divide by 3.
And we'll go ahead and estimate on our calculator. 50 divided by 3 to the nearest 10th. Now we could leave it in fraction, that's fine.
16.7.
Okay, so to the nearest 10th, about 16.7. How will we use that to find the measure of angle? Well,
Put it in
that
for
was kind
x.
of a dumb question, wasn't it? It's 60.
Yeah.
So it's 60. But anyways, I would put it in, is what I was getting at there. So I should have said find x.
Wait,
That would've
how
made
do you put it in?
35.4.
You take this and you put it to replace x. So it'd be 2 times 16.7. That will give me this piece. And if I want this piece, 16.7 plus 10. I just replace the variable with what is equal to.
Okay.
Let's say I have a straight angle.
180.
Yep, it's 180 degrees. So this is 180 degrees. And let's say this is x plus 7. And let's say this is 2x minus 10. Set up some way that I can find the value of angle A, B, C. So now this time I'll actually do it right. What should we write?
2x minus 7.
X plus
Plus x plus x plus 7.
Equals 180.
equals 1.
Because how many degrees are in a straight angle?
180.
180. Now I go ahead and solve this. So I combine those, get 3x minus 3 equals 180. Now
Add
what?
3.
183.
And then divide that by 3.
And what do we get to the nearest 10th?
61.
61. Exactly.
Okay?
But then
Now, if
60
I want,
for
yep.
x.
If I want angle ABC, so we're going to find the measure of angle ABC, I'm going to put the 61 into there. So I get 2 times 61 minus 10. So I do 2 times 61.
2,
122.
Minus 10.
112.
Holy.
So 112 degrees. If I wanted this angle, what would I do now?
Then you
Plus
just
61 plus 7, which would be 68.
That's one way. What's another way?
Subtract it.
I could take this and insert 112 and subtract it from 180. I'll get the same thing either way. It's just a matter of which happens to be easier at that time. All right, try this one. What kind of angle is this?
90 degrees.
So I have 90 degrees. Find the value of x.
Honest?
Set it up, Evan.
2x plus 3x equals 90.
Yep. Now what?
5x equals 90. Then you divide by 5 and you get 18.
Okay, because I asked for x, we are done. Okay? Any questions how to do this?
They wouldn't solve it.
We did solve it.
They're not like funny.
And you would put it back in if you're asked for a specific part. So if I
Oh,
said
okay.
A, B, C right here,
Oh,
angle
yeah,
A, B, C,
I see.
then you would put the 18 in and get the part. Okay? We could have, now this one is going to be a definition. So I'm going to give you two definitions. They go into your notes, and they also go into that special section that you need to be constructing so that you have these. So we already talked about this earlier in the week, but we had midpoint. So that's not really too much to do with angles, but midpoint is a point that divides a segment into two congruent halves. So that one we've already talked about, but that's a definition. So sometimes you'll be proving something, and the reason that you say a specific thing in your proof will be because, and you're right, definition of midpoint. This other one is also common. Bisector. And we have two different kinds of bisectors. We have a segment bisector, and we have an angle bisector. So we have two different ones, but they do the same thing. A bisector is it could be a segment, a ray, a line. It could be any geometric shape. That divides a segment or angle, depending upon which one you have, into two congruent halves. So a midpoint is only going to apply for a segment, and a segment bisector will form a midpoint on something. A bisector, really, we use, for the most part, in conjunction with angles.
Mr. Kane, what did you say that equal sign stand for?
This is,
Congruent.
okay, yep, and that's actually another one. So there's actually three things. Congruent. And this is going to get into a trick of geometry that you need to be aware of. Technically, congruent and equal are two different things. Okay, congruent means that I have the same shape and it's the same size. So I have two shapes that are the same shape, same size. Same proportion, same everything. Everything's the same about that. As a result of congruent, and this is important, it results in equal that symbol, sides and angles. So like congruent is slightly more powerful, I guess, than equal.
This is doing that section too.
Yep, that would be, that's something you will have to use in proofs too. You'll say two things are equal because they are congruent. Coleman's like, oh gosh. All right, let's do one more algebra. I'll give you a second to wrap that up, and then we'll do some
Okay, while they're wrapping it
worksheet
up,
stuff.
what's the name of the section again?
Are you going to give a definition? For
You
the
mean-
segment?
Yeah, for the definitions and all that.
You don't need to title it anything. It's just your bank of
Definitions.
So you're going
definitions.
to give us the definition for the segment and the angle bisector and function.
It's the same. Okay, if you're talking about a segment, then it's a geometric shape that divides a segment into two equal halves. If you're talking about an angle, it's a geometric shape that divides an angle into two equal halves. So I use the same one definition, but it's two different things. When you're doing your proofs, you can say definition of bisector, and the context will give us whether we're talking about an angle or not.
So segment addition will be the first one that we've done so far?
Yep. Okay, so we have segment addition, angle addition, midpoint, bisector, and congruent. So we have what, 5 things in that special area. Okay, so let's use angle bisector. So let's say I have this angle right here, and I say this is 5x minus 10. Let's say this is 2x plus 15. Again, I made up these, so who knows what'll happen. Anything can happen. Let's say I want to find the value of x, and let's say I want to find the measure of angle A, X. Well, that's going to be confusing. B, C. So we'll do both of those. How could I find x if ray BD bisects angle ABC? So notice I gave you some information. I told you this ray BD, bisects the angle. So what does that mean about these two?
They're congruent.
They're equal.
They're congruent, they're equal.
So 2x plus 15 equals 5x minus 2.
Yep. So I set them equal. So we do need to be careful whether things are going to be equaling each other or whether I add them together to get something else. That's going to be a key thing. So what do we do now?
Get like term pieces inside.
So subtract the 2x,
And add the 10.
add the 10, and then
Divide by 3.
divide by 3. What do we do with this in order to find the measure of angle ABC?
Plug it into the 5x.
Okay, we plug it into either one of these. So it doesn't matter which one, I'll plug it into this one. So that'll be 25 thirds times 2 plus 15. So that's 50 over 3 plus 15. How do I add those? How do I add 50 over 3 to 15?
Get a common denominator.
Yeah, I need a common denominator. What's the common denominator? So multiply by 3, multiply by 3, I should get 45. So I get 95 thirds. That's the measure of that angle. But that's not the answer to this question. Okay, that's this piece. What do I need to do to that answer to get the whole thing?
Multiply it by 2.
Multiply it by 2. So times 2. So 195 times 2 is
290.
290?
I don't know.
You do not know.
That's a guess.
95 times 2.
49.
190.
190. So we have 190 over 3.
That's complicated.
That is the final thing. You should know how to do fractions, multiply, divide, add, subtract.
I'm just saying that's a bunch of writing.
Yes, it is. Okay, we'll stop there. And